Okay, hi everybody. We're just looking at rational functions, and the intention of this question is to find the horizontal and vertical asymptotes of these values here, these expressions here. So the first thing I want to do is factor, and here I'm going to factor the numerator to get x plus 3, x minus 3, all over 3x plus 2. Now in this case right here, nothing's canceling. There's nothing common numerator to denominator, so I'm not going to get a point discontinuity. So just take a look at the denominator here, and I see that this is going to become undefined. The denominator goes to 0 at negative 2/3, so that becomes my vertical asymptote. Okay. To find my horizontal asymptote, I'm going to compare the degrees of the numerator and denominator. And notice that for very, very large values of x, the dominant term in the numerator will be x squared. The dominant term in the denominator will be just 3x. Okay, because the minus 9 up here and the plus 2, if you're talking about extraordinarily large values of x, well, those numbers aren't going to mean much of anything. Now, if you cancel out the common value of x here, the common factor of x, you get x over 3. Now, this is a different thing here altogether than what we've seen previous. If x gets large, this whole thing gets large. Okay, so this isn't going to approach a specific value. If x is in the denominator, and as x gets large, that whole thing approaches 0. The fraction gets smaller and smaller. But here, it's just going to get bigger and bigger without bound. It's not going to be approaching any specific number. So what happens here is for my horizontal asymptote, turns out there is none. Okay? All we've got here is that vertical asymptote at negative 2/3. And that's going to be true if the degree of the numerator is larger than the degree of the denominator.